Hello everyone. Today I am going to discuss friction circle method. Friction circle method is by using this method we will do the analysis of a stability of slope. There are the other method also, but now I am going to discuss friction circle method. So the friction circle method is based on the total stress analysis, and it is basically for the homogeneous soil. So there is other assumption also, like slip surface or whatever the soil which is inside the slip circle would be a homogeneous, and in this case the slip surface would be circular. Slip surface would be circular, or we can say slip surface is the arc of circle. So there are 2-3 assumptions, and by deriving this method or by deriving any equation in this case, you have to first understand what are the assumptions. So the very important assumption is slip surface is circular. So in the figure there is a mention of force, friction, circle analysis and force triangle. So in the case of A part, so whatever the soil which is inside the slip surface or slip circle, that is A, B, C, A, B a straight, B, C a straight, and then C to A there is an arc, and this AC is the slip surface, and the arc of AC is the arc of a circle. So whatever the slip surface, AC is the arc of a circle. So there is assumption of, so AC would be a arc of a circle. Okay, I am not talking about the chord of AC. Chord of AC is a straight line, but I am talking about the curve, and that curve is a circle, the part of a circle, AC. So by suppose there is a slippage occurring through the slip surface AC, and the slipping mass ABCA. So for the equilibrium condition, there are 3 forces which are acting to make it in equilibrium condition. 3 forces. The first one, weight, that is W. Weight of the soil which is inside the slip circle, and this weight will act at the centroid of the slip soil mass, or slipping mass we can say, or sliding mass we can say. So whatever the centroid of ABCA, so the total weight will act vertically, downward vertically at that point. Okay, at that vertically from the center of gravity. Okay, the first force is the weight. The second is the P, that is total reaction, or we can say resultant reaction. So total P will act, that is angle phi m with the normal of slip surface. So the total reaction P will act as phi m angle to the normal of slip surface, and the third force, that is cohesive resistance that is offering by a soil along the slip surface. So that is mentioned by C. So to make it equilibrium, to make of this sliding mass in equilibrium, there are 3 forces: weight W, P total reaction or total reaction resistance, or C, that is total cohesive resistance along the slip surface. Okay, so the reaction P is inclined at an angle phi m to the normal of the slip surface. Okay, and this phi m we can calculate by using this formula: tan phi m is equal to tan phi u divided by f phi, by assuming the value of f phi. Suppose during this analysis we have taken some assumption of f phi. So by using the assumption value of f phi, we can calculate phi m, and we can calculate the angle of reaction P with the normal of slip surface. Right? Suppose just assume there is a there is an element of delta L, and we will do the analysis for delta L. So now we have taken the delta L, a very short length on the slip surface of AC. So the elementary cohesive force, so what are the cohesive force for this element delta L, will be Cm into delta L. Cm into delta L. So what is the Cm? Cm is the unit mobilized cohesion, and which is constant along the slip surface. So there is another assumption also, that is Cm is unit mobilized cohesion, and that is constant along the slip surface. Cm will not vary, Cm is constant. So suppose this elementary cohesive force for element delta L, Cm into delta L. So if we will take the total elementary cohesive force for total length L, so that would become Cm into L. Cm into L. It means we are writing the cohesive force along the surface of AC. Right. So now, but you will see that for every element, the direction of this cohesive force is varying, because the AC surface is a curved surface. AC slip surface is a curve. That is arc of a circle. Means at every point, for every element, this value is changing. The direction is changing. And suppose the reaction at that element, that is delta P. So that delta P will be also phi m and angle of phi m with the normal of slip surface, and that is also variable. The direction is variable. So now for that, for the easily analysis, what we can do? So what we can do here, so just assume that the cohesive force, whatever the acting at the slip surface, that is acting parallel to the chord AC, and that parallel to the chord AC. So what is the length of chord AC? So suppose length of chord AC is LC. Length of chord, in short we can write LC. So LC is the length of the chord. So we can write the resultant cohesive force Cm into LC. Cm is the unit mobilized cohesion along the slip surface. But now we are not working at the slip surface. Okay, just be careful. So we can write Cm into LC. So whatever this resultant cohesive force, we can find the position of it. What are the position? Means this force, where is acting in this figure? Where is acting? So to find the position, what we can do? We can equate the moment about the center O. So the moments of all the elementary, that is delta L cohesive force along the slip circle about the center of rotation O to the moments of the resultant about O. So we can write like this. Are you getting my point? Cm into delta L, that is elementary cohesive force for element delta L, and what are the distance from the O? So that is R, capital R, because capital R is the radius of a circle, radius of slip circle. Okay, so we can write Cm into delta L into R. So that will become a moment. Again, for the terms of resultant cohesive force, so Cm into Lc. So suppose A is the distance of this force from the O, from the center O, where this O is the center of slip circle. So we can write, using this equation, we can calculate the value of A. Cm will be cancelled. So we can write A is equal to L divided by Lc into R. So obviously in this case we will see that Lc is the chord of a circle and L is the length of arc of a circle. For AC, AC is the arc. So obviously here in this case L would be greater than Lc. If the L is greater than Lc, so obviously A would be greater than R. Or in this case R is the radius of a slip circle. So A is greater than R. It means that whatever the location of this force, this resultant cohesive force Cm into Lc, that would outward from the slip surface that will be beyond the circle. So that is mentioned in this figure. You can see that this is the intersection point of W, P and Cm into Lc is outside from the slip circle. So the line of action of delta P will be the tangent. There are two things. Delta P is the reaction for the element delta L. So that will be at an angle phi m to the normal of the friction, normal of the slip surface, and the total reaction P will be also phi m angle to the normal of the slip surface. So the line of action of delta V will be the tangent to the circle. So all the delta P will be the tangent of a circle, and that circle is called friction circle. That is mentioned in the figure. That is called friction circle or phi circle. And the radius of phi circle would be r sin phi. In the gate examination, once it's asked, what is the radius of friction circle? So the radius of friction circle is r sin phi, where r is the radius of slip circle. Okay, capital R is the radius of slip circle. And r sin phi, or you can say r sin phi m. R sin phi m is the radius of friction circle. So see, so now we can draw the force triangle. For drawing the force triangle, whatever the three forces which is acting for the making it equilibrium of ABCA. So W will act as the center of gravity of ABCA or center of gravity of soil, which is inside the slip circle. W will act vertically downward. P, the total reaction, will act phi m and at an angle with the normal of slip circle, the resultant, or C, which is CA into LC, that is parallel to the chord AC. The direction of C is the parallel to the chord AC. So in this force triangle, you will see you have the W value, you have the angle of P, you have the angle of C. So by knowing the W value and by knowing the all angle, we can calculate the P value, we can calculate the C value. Means we can calculate the CM into the LC. So once we have the C, once we have the CM into LC, so from the force triangle we can calculate CM, unit mobilized cohesion, which was constant along the slip surface. So we can calculate CM is equal to C by LC. And once we have the CM value, we can calculate the factor of safety with respect to cohesion by using the formula FC is equal to Cu by Cm. So once FC value we have, and in the beginning we have taken the assumption of phi, F phi. So if whatever they have taken assumption of F phi, if F phi will be equal to FC, it means our assumption is correct. We have taken the right assumption. Okay, and an analysis is done, and an analysis is completed. But if when whatever they have taken the assumption of F phi value is not equal to FC, it means that our assumption is wrong. So what we will do, we will take another assumption. All the analysis we will repeat again. Okay, again we will assume the value of F phi, and we will see what are the value of FC is coming, and if both are equal. So this analysis we will repeat it till F phi will be equal to FC, or once F phi is equal to FC means our analysis is done. Okay, so in this friction circle only you have to remember the two things. What are the forces, like three forces W, P, C, what are the angle of this, and what are the Cm into LC. Like Cm into LC, we have assumed some resultant cohesive force acting along the parallel to the AC, chord of AC, and we have taken the A distance, we have calculated the A distance. A is the position of Cm into LC cohesive force from this O, and we got A is greater than R, means this intersection point will be outside from the slip circle. So the three things are important to understand this friction circle method. Okay, and all the total reaction, that is P, which is tangent on a circle, and that circle is called friction circle or phi circle, and the radius of phi circle or friction circle is r sin phi m or r sin phi, we can write. Are you getting my point? Okay, so let's discuss some numerical problem. Numerical method, not numerical method, numerical problem. It would be numerical problem. Okay, so the first question we have: for the construction of a highway, a cut is to be made as shown in the figure. The soil exists C dash 20 kilopascal, phi dash 18 degree, and the undrained shear strength 80 kilopascal. The unit weight of water is 9.81 kg per meter cube. The unit weight of soil above and below the ground level, water table are 18 and 20. So unit weight of soil above the water table, that is 18, and below the water table, that is 20 kg per meter cube, respectively. If the shear stress at a point is 50 kilopascal, the factor of safety against the shear failure at this point. So we have to calculate the factor of safety at a point where the shear stress at a point is 50 kilopascal. Considering the undrained and drained condition respectively would be. So we have to calculate factor of safety in the case of undrained condition or in the case of drained condition at a point where the shear stress is given, that is 50 kilopascal. So I have discussed in the previous lecture also the factor of safety is that it is the ratio of shear strength to the shear stress, where we are calculating. So we are calculating at a point where the shear stress is 50 kilopascal. So we have the tau value. So we have to calculate the shear strength like S, like tau, whatever. So factor of safety we can calculate for the undrained condition. In the question you can see the undrained shear strength is given. Shear strength S for undrained condition is given 80 kilopascal. So for undrained condition we have the S value also. So we can take the ratio. The factor of safety will be equal to ratio of resisting shear strength, that is S, dividing the actual shear strength, that is tau. So for undrained condition, shear strength is given 80 and shear stress is given 50. So we got the factor of safety 1.6. Now case 2, drain condition. So for the drain condition, again we can apply this formula. So acting shear stress or shear stress at that point is 50 kilopascal, that is given. Tau is given. So now condition is changed. Now drain condition. So we can apply C dash plus sigma dash 10 phi. So in this case, C dash we have, phi dash we have to calculate sigma dash. So what is the sigma dash? Sigma dash is the effective normal stress. Effective normal stress that we can calculate. So how we can calculate? See, we have to calculate at a point P, what is the undrained shear strength, drained shear strength at a point A. Or you can see in the figure, point A is lying 6 meters below the slope surface. But water table is lying 2 meters below the slope surface. It means whatever the soil is placed, soil is above the point A and below the slope surface. So from the top up to 2 meters, soil is above the water table, and then again 4 meters soil is below the water table. So we can calculate the unit weight. So C dash, just put the value of 20 that is given in the question. 10 phi, that is given 18 degree. Okay, 10 80 degree. Now we can calculate sigma dash. So whatever the soil above the water table is 2 meters. So 2 into 18, unit weight of soil is 18. 2 into 18 plus. Now we can write submerged because the effective stress we have to calculate. Okay. So 4, what is the distance of this submerged height of soil is 4 meter. So 20 is the saturated unit weight minus gamma W, 9.81 means 20 minus 8.9.81, that is submerged unit weight. So by writing this expression, we can write sigma dash. And by calculating the value of this C dash plus sigma dash 10.5 divided by 50, we can get 0.9. 0.9. So in this case, in this question, the undrained shear strength was directly given. Shear stress was given when we are calculating at a point A in both the cases, and factor of safety we have calculated for drain condition, undrained condition. Right? Okay. Next question we have the critical slip circle for a slope is shown in the figure along the soil property C is equal to 30 kilonewton per meter cube per meter square. The length of arc of a slip circle is 15.6 meter. The area of the soil within the slip circle is 82 meter square. The radius of the slip circle is 10.3 meter. Unit weight of soil in slip circle is 20 kN per meter cube. The factor of safety against the slip circle failure is equal to. So in every condition, when you are we are doing the analysis in the terms of in the case of critical slip circle. So factor of safety we can calculate in terms of moment. So factor of safety we can calculate by taking the ratio of resisting moment to the distributing moment or to the equating moment. Right? So what are the resisting moment? So whatever the resistance is applied along the surface, along the slip surface, so whatever the moment of that, we can count as a resisting moment. And whatever the moment that is coming by the load and external forces or reaction, so that will become a distributing moment. I get my point? Okay. So we have the C value, we have the radius R value, we have the area which is soil within the slip circle is 82 meter square. We have the radius of slip circle 13.3 meter. We have the arc of length also, that is okay. Unit weight of L we have, and the unit weight of soil is given. Okay. So now we can calculate the factor of safety. See, we have L. L is the length of slip surface. Okay, gamma is given, unit weight is given 20. R is the radius of slip circle is given 10.3. Okay, A is given 82. So factor of safety we can calculate by resisting moment to the equating moment. So what are the resisting moment? See, to resisting moment we can calculate where resistance is applied along the slip surface and why it is there. Like resistance is applied by the cohesion. So we can write C into L. C into L means unit cohesion into L. It means the whatever the force, cohesive force per unit length. Or suppose the length of this picture, length of perpendicular to this picture is 1, right? And R. So what are the radius of the slip circle? So the moment C into L into R, that is moment. That is resisting moment. Okay, an equating moment, we can write W into 2.3. So what is meaning of W into 2.3? See, whatever the weight is acting, that is the centroid, which is 2.3 distance from the O. That is given in the question. Okay, that is 2.3. So we will take the moment. So weight into perpendicular distance, W into perpendicular distance from the O. So that will be 2.3. So we can write W into 2.3. So in this case, we have the C value, we have the L value, we have the R value. Okay. In this case, a small is equal to a capital R, small r is equal to capital R, W. So we have calculated the W. So how we can calculate the W? So what is the W? W is the weight of soil within the slip circle. Okay, but that is not given in the question. But in the question, you will see the area is given. Whatever the cross-section area of a slip soil of within the slip circle is given, and we have the unit weight. So we can calculate the weight per unit length. That is length is perpendicular to this figure. So we can calculate weight of soil. So area into unit weight into 1. Okay. So 82 into 1, that is volume of soil within the slip circle. So we can calculate weight. So that is 1640 in kilonewton. So now we have all the value. By putting all this value in this above equation, so we can get 1.28. Okay, so in this question or these types of question, you have to just calculate the resisting moment. So what are the resisting moment? Resisting moment is also applied, is only applied because resistance is occur due to the cohesive. A cohesive is acting that along the slip surface. So cohesion into length of slip surface, okay, or into R, what is the radius of slip circle. So that will become a resisting moment. Next question we have, for the trial slip circle shown in the figure below, calculated factor of safety. The data weight of the soil is given 346 kN per meter. Unit weight of soil is given 19 kN per meter cube. Here 19 kilonewton per meter cube. Okay, where the Cu is equal to 20 kN per meter square. So this is the figure. So in this case, you can see the weight is acting vertically downward, and that is 5 meter from the center. Radius is also given 9 meter. But in this case, length is not given. Length of slip circle is not given. So length we can calculate. So how we can calculate the length? So this formula we can apply factor of safety. So length we can calculate by using this relation. Angle is equal to arc divided by radius. Arc divided by radius. So angle we have 70 degree. Radius we have 9 meter. So we can calculate the arc. Means length of arc. So we can calculate L is equal to 10.995 meter. L is equal to 10.995 meter. This L is the length of arc of a slip surface or length of slip surface. Okay. So again we have this formula. Resisting moment we can write C, that is cohesion, into L, length, into R, that is the radius of slip circle, that is 9 meter. W we can write, so W is given 346 kN per meter, and the distance is given from the O 5 meter. Perpendicular distance is given 5 meter. So by putting all the values in this equation, we got factor of safety equal to 1.14. Next question we have, for the given surface, and this question is important. Little bit it is important. Okay. For the given surface, determine the factor of safety in terms of total stress for the slope given in the figure. Figure is mentioned. So the unit weight of the both soil 1 and 2 is 19. So unit weight is given for both soil is same, that is 19 kilonewton per meter cube. For the soil 1, the relevant shear strength parameter are Cu is equal to 20 and phi 0. For the soil 2, Cu 25 and phi 0. And all the dimension and the area of the soil which is inside the slip circle is given 41.7 meter square, and the length and dimension are given. Okay. So now by knowing all dimension, we can write, see, the angle at A is given 45 degree, and the vertical distance between the A and D is given 3 meter. So by angle 45 degree, the horizontal distance would be also 3 meter. Are you getting my point? So horizontal distance between the A and D would be 3 meter. So now we can calculate the radius. How we can calculate? So the vertical distance between A and O, is 3 plus 4 plus 1.5, that is 8.5. Okay, and horizontal distance between A and O is 3 meter. So by using the Pythagoras formula, we can write R is equal to root under 8.5 square plus 3 square, that would be 9.014. right? Okay. So now we can calculate theta 2 angle AOD, theta 2, that is mentioned in the figure. So by applying the trigonometric equation, we can calculate the theta 2. So theta 2 would be the sine inverse 3 by 8.5, and it would be 20.67 degree. 20.67 degree. Clear? Okay. Now we can calculate the theta 2. Theta 2 is the angle DOC. Theta 1. DOC. So again we can apply the trigonometric rule and we can calculate the theta 1. So how we can calculate theta 1? So see, if you will draw a line, horizontal line from the C, then it will cut the vertical line OD at some point. So the whatever the points, and the vertical height would be 1.5, right? Okay, and the horizontal distance will be something. Okay, that is not known. But OC, OC is given 9.014. So for calculating the theta 1, the OC is given, and whatever the the vertical distance of this is given 1.5 meter, right? So we can calculate the theta 1. Are you getting a point? By drawing a line, horizontal line from the point C, and it will cut the OD line, vertical line at some point, and the vertical distance of this 1.5 meter is given, and this radius is given, that is OC 9.014 meter. So we can calculate the cos inverse of 1.5 divided by 9.014 will be 80.42 degree. 80.42 degree, 42 degree. Again we can calculate, see, another angle, because see, the soil above the point B up to the B to C there is a soil 1, there is other type of soil 1. Below the point B to A there is a soil 2, there is other soil, that is 2, soil 2. Okay, so suppose the angle BOC alpha, which is mentioned in the figure, so we can calculate the alpha. So now we will see that at an angle DOB, at an angle DOB would be theta 1 minus alpha, and that we can write, because the distance of OD length, we can write 4 plus 1.5, that would be 5.5, and again OB will be the radius. What is the length of OB? The length of OA, OB, OC, these are the radius of a slip circle. So OA, OB and OC will be the same. So we have the OB value and we have the OD. So we can calculate the theta 1 minus alpha by taking the cos inverse of 5.5 divided by 9.014, and that would be equal to 52.4 degree. So we have already calculated theta 1. So by putting the value of theta 1, we can calculate alpha, and that is 28.02 degree. That is 28.02 degree. We have just applied all the trigonometric rule, and we are calculating the theta 1, r, theta 2 and alpha, right? Now we can go for the calculation of length of a arc, length of a slip circle. So the length of slip circle in the case of soil 1, how we can calculate? So the curve of B to C, the length of curve of B to C will be the length of soil 1. Okay, so again we have the angle and we have the radius, so we can calculate. That will become a 4.4, because I told you in the previous slides, like the angle is equal to arc by radius. Angle is equal to arc by radius. So in this case we have to calculate the length of a arc, so radius into angle. So radius into angle. So what is the radius? 9.014. So length of a soil, length of a arc in the case of soil 1, that is 4.408 meter. Similarly, we can calculate the length for the soil 2. But see, the length of soil, whatever the angle AOB, so AOB you will see, then you can write theta 2 plus theta 1 minus alpha. Theta 2 plus theta 1 minus alpha. That is angle AOB into radius. So we can write 9.014. Okay. See why we am into multiplying with 5 and dividing by 180 degree. See these are because whatever the angle we have calculated, that is in the form of degree. So we have to do in the equation we have to write in the terms of radian. So for the radius we have to convert. So there is a conversion that we have to apply 5 divided by 180 degree, or we can write also 2 pi divided by 360 degree. Both are equal. In some books you will see they have written 2 pi divided by 360, but both are equal. Okay. So length of arc in the case of soil 2, that we got 11.49 meter. So now we can go for the calculating the resisting moment. So resisting moment we can calculate. So what are the resisting moments? C into L into R. C cohesion, L length, and R is the radius of slip circle. So in the case of soil 1, so 20, what are the length? 4.408. What is the radius? 9 point. In the case of soil 2, length, unit weight and radius. C means C is given 25. So that we get 3383.94. Okay. So now we can calculate distributive moment or equating moment. So see how we can calculate. So for calculating the moment, we have to calculate the weight, and then we will just write the distance. So in the figure you can see the weight is acting at some point, and that weight perpendicular distance between the weight and the line of action of weight and to the O is given 2 meter plus 1.5 meter. 2 meter plus 1.5 meter is given. So it would be 3.9 meter. And area is given. Area is given 41.7. So area into unit weight into perpendicular distance between the line of action of weight to the O. That is 2 plus 1.9. So that is also we get 3089.97. So we have calculated the resisting moment and equating moment. So now we can take the ratio and we can calculate the factor of safety. So factor of safety we can calculate 3383.94 and 3089.97. So we get 1.09. 1.09. See, in this case you will see, or in the previous cases we have seen, there is only one type of soil. There was only one type of soil, but in this case there is two type of soil. So don't confuse with that. Whatever the there are too many type of soil, like their unit weight is changing, whatever. Only you have to focus what are the C value, what are the L value, what are the radius. Radius would be almost constant. Okay. So in that we have calculated the resisting moment for each soil. Like in this case we have calculated the resisting moment for the soil 1. Then we have added the soil 2. Suppose there is other soil 3 also. So we can calculate C into L into R for the third soil. Okay. And in all the cases, that equating moment will be constant, weight into perpendicular distance between the line of action of weight to the O. Are you getting my point? Okay. So these are the references that I have taken, and if any problem, from the next class I will start the unit 2, that is bearing capacity of a soil, bearing capacity of Terzaghi theory. I will discuss all those things, okay, thank you.